2, 1. Hey everyone, what's up? Welcome to Simulation. I'm your host, Alan Sakyan. We are sitting down with Ahmed Amer. What's up?
It's a pleasure to be here, Alan.
Thanks for coming on the show.
Thank you for having me.
I appreciate it. And so we are going to be talking about data. We're going to be talking about storage. We're going to be talking about systems. We're going to be talking about general data privacy. We're going to be talking about, yeah, I know. We're going to be talking about the memory, yes.
Okay.
So give us a little bit of a taste into the last couple of years of your research and what you've been up to and what your understanding of this is, because I'm super fascinated and excited to learn.
So I'm probably known as a storage systems researcher. And I teach operating systems. And one of the fun questions that sometimes comes up is, well, what does that mean? Right, what does it mean to work on system software related to storage and system software in general? And the rather embarrassing answer is, when people ask, well, what does your work do? The embarrassing answer is nothing you'd notice if we're doing it right.
But we kind of do notice it as you're doing it right, because you're doing a good job at decreasing cost, at increasing storage capacity, right? That kind of stuff.
So a large part of that has to do with the way hardware develops and technologies change. But a significant part of it is also how we use it. So if somebody were to tell you, to use a car analogy, your car can go a certain distance and can go at a certain speed. But if I futz with its software a little bit, I can make it go farther or I can make it go faster. Would you attribute that to the software, or would you attribute that to the power of the engine? Intuitively, we tend to attribute it to the underlying hardware. We don't generally think about what the software is doing, except that it's managing the resources we have as efficiently as possible. Yeah. And if it's not doing that, then it's wasting our resources. And so we only notice it when it's doing something bad. The equivalent on the systems end of things is your computer has a bunch of resources available to you. Your storage has volume to it. It has certain performance characteristics. And some of those characteristics have improved dramatically over time, especially the volume. So if I told you a year ago you'd be able to buy more than a terabyte for less than $100, if I told you that a decade ago, you would have thought, no, that doesn't sound quite right. So what does it mean to trade speed for capacity, for example? If your capacity is cheap and you've got lots of it, and you want to go out there and pull data from somewhere else, hoarding large quantities of it nearby on your hard drive is burning space. But it's giving you speed because you don't have to go out and fetch that data again. Mm-hmm. So algorithms like that manage caching, or you see them more in things like CDNs pushing data to the web so you don't have to cross the planet to pull the same websites.
CDN right now.
Exactly.
Yeah.
So that's a layer of software where if it doesn't work, you notice and you get angry at it. But when it is working, you don't usually attribute the performance to it, right?
You actually taught me about this. So you maximize anticipation of future requests.
That's one of the techniques we've used to improve storage performance. So that's actually a really fun example. If I told you you're going to want certain pieces of data in the future, and I'm going to try to figure out what those pieces of data are before you want them.
Yeah.
Now, the intuitive way to take advantage of that is to go out and get that data before you actually ask for it. So,
like right now, what I'm imagining is my solid state drive on my computer, and I'm thinking of my operating system observing me opening a folder that has that will want that will almost certainly want me to have certain files easily accessible, and then it going and pulling the data from the cloud onto the SSD, and then making it easily accessible for me to use rapidly, and then when I'm done with it, putting it off of the SSD.
So that's exactly right. On another level of it, you could imagine if that folder is a folder you keep opening a lot, the files on it don't necessarily have to be left on the drive. They're pulled up into a memory cache, so you don't even access the drive as often. So that's the intuitive way of trying to improve performance by figuring out what's going to happen next, right? But that's been common and it's been around for decades now in one form or another. What tends to change is the techniques we use and how good we get at figuring out what's going to happen next. That changes a little bit from time to time. But another way to think about it, and that's where I think that's a really fun example, is if you knew all the future requests that somebody was going to make, what would be the best thing to do with that information? Fetch the data and bring it nearby? Yeah, that sounds like a good idea. But fetch it from where? From a distant place and bring it close to you? Well, sometimes that distant place is also nearby, but there's variations in how far away they are. So it might be better for you to not even bring the data in, but to instead say to yourself, look, if I notice that this tends to happen after that all the time, I should bring those two pieces of data together and store them in the same place together. So instead of you going out and saying, I'm going to figure out what you're going to do next, and I'm going to go out and get that data and bring it in, instead you just say, no. Read your data in bigger chunks. And because I've placed the stuff you're going to want next close by, just doing that has the same effect. And that actually has a really fascinating side effect. I apologize if I'm getting too nitty-gritty here with this, but if you consider that traveling to different locations and making the requests has a cost.
Totally does.
Time and energy, perhaps. By doing that co-location, by bringing together the data that will be accessed together, you reduce the number of operations you do, which means that you would be reducing both time and energy. So going back to the car analogy, it's like me asking you, would you like your car to run faster or go further? And then you telling me, I can't decide. And I say, don't worry about it, we can do both. By doing that, instead of going out and fetching from wherever it is and not relocating things, that's one of those cases where just shifting your perspective, how do you use that information? Just the way you use it, no change in the information itself, gives you a win-win in a situation that otherwise would have been considered a trade-off. So,
this is so good. The car analogy is good too. And so is just making this really applicable for people to understand. So let me take us back a little bit just to the very beginning. So, with storage systems research, initially there's hardware, like a hard drive, and there's the software that writes the ones and zeros onto the hard drive.
Yes.
And you can optimize both the software and the hardware.
So optimizing the hardware is something that storage systems researchers who specialize in that do. I'm more of on the software end of things.
So now furthermore is we have the hardware optimization, which is like the engine and the axis and wheels and these other components of the car.
Yes.
And then we have the software, which is kind of like the computer inside of the car.
Yes.
And so then, what are some of the ways in the last decade or so, as you've been in figuring out how to maximize the software of writing ones zeros to the hardware? What has been like an optimizing, because we talked about the anticipating future requests. What other like ones can you bring up for us?
So you're asking an amazingly good question there, because it goes deeper than what are the best ways to make things faster or more efficient. I mean, efficiency is always going to be a big deal because let's put this in perspective. How much data is there? That's
oh my God! So
okay.
it's like every what is it? It's like in the last 2 years it's all 90% of all the data that's ever been made is made in the last 2 years.
That is
so
that is an amazing way of looking at it. Another way of looking at it, and I'm very cautious about stating numbers on that because the ways people estimate it vary rather dramatically.
Yeah.
But if you asked me that question 5 years ago, I would have been talking about things in the exabyte ranges per year. We're generating exabytes of new data per year. Ask me that now, I'll be talking. Oh, we're talking in the zettabyte ranges, and this is just less than a decade's difference. Where we're talking about orders of magnitude, massively more amount of data.
Yeah.
To put that in perspective, an exabyte would be today a few rack enclosures in a data center.
Exabyte's 1,000 petabytes?
So sorry, let me put that, I misspoke there. A petabyte would be a few enclosures.
Petabyte's 1,000 terabytes.
A petabyte is, yes, if, let's say 1,000.
Yeah.
An exabyte would be 1,000 more than that.
Okay. And Zeta is 1,000 more than that.
And Zeta is 1,000 more than that. So when you talk about a petabyte, you can imagine a petabyte being a couple of cupboards worth of space. An exabyte, you're talking about a fairly substantial data center, like a 4-story building on a city block, right? That's an exabyte. So when you start talking about a zettabyte, though, you're talking about, some estimates would be, let's take 20% of Manhattan, turn it into data centers, maybe we'll have enough room then. That's phenomenal, right?
Wow.
So that leaves you with a certain awe at the scale of the problem of how much data.
Per day?
Oh, no. We're talking about zettabytes per year.
Per year, okay.
But that's the new data generated. Where's the old data going?
Yeah.
We still got that.
Yeah.
But the
hopefully into DNA. Hopefully into DNA, which is
that's a fascinating thing.
Yeah.
Because we recently had a very interesting debate at the mass storage conference between one gentleman explaining the realities of what it would cost to build DNA storage today, and another gentleman explaining the technology trends that might make it actually feasible in terms of cost. So to put that cost thing in perspective.
Where's Catalog there? The DNA company?
A Twist Bioscience were one of the ones who make the synthetic DNA. Cool. And but forgive me for going back to the exabytes versus zettabytes. So what's after zettabytes, right? It's yottabytes or yobibytes, depending on which terminology and phrasing you want to use. But if you take an exabyte as 2 to the power 60, the one after the zettabyte would be 2 to the power 70. So can you imagine we'd go up to 2 to the power 80? I'd like to throw that number out there and say, yes, maybe we could imagine that. But that would be foolish of me. Because if you looked at what that would take in terms of data centers, we'd basically have to dedicate a couple of states to it. Maybe take Delaware and Rhode Island and turn them into big data center farms, and then we'd be able to store a yottabyte.
So this data storage within conventional methods is not sustainable at all.
Those are famous lost words, because not that long ago people were saying the magnetic hard drive would be long gone and dead by now, but we're still using them because of cost per capacity. So if you're talking about an order of magnitude greater than zettabytes, you're talking about just the cost to build the storage is, I believe one estimate, something like 30 to 40 times global GDP. It's on the order of $100 or so trillion. So that's not feasible now, but the famous lost words is when somebody tells you something's not feasible based on an estimate like that, and something radically changes in technology that changes the costs, and then they're proven wrong and foolish.
And so some of the software that you've written that has helped write onto hard drives.
Oh, I wouldn't claim anything so dramatic
Yeah,
as...
you're directing. But
Because, well, there's something actually you said a while back which had to do with educating the public.
Yeah.
And
making it relatable. Yeah.
Oh, exactly.
Yeah.
So
That's what we do on the show.
Well,
we make things relatable.
So what's research, right? What's the difference between research and education? Are they both scholarship or not? And so one answer to that, one perspective on that is size of audience. So you're breaking new ground and discovering something absolutely nobody's thought of or seen before. Who are you educating? Yourself at that moment. When you verify those results and share them with the research community, who are you educating? Experts in your field who are a small group of people who specialize in that. When you're communicating those research ideas to a broader community across disciplines and then to the public, who are you educating? A broader audience. So when you think about it, everything all the way up is you're educating. Right? So the reason I mention that is I would never be so pompous as to say my work has changed something in that way, but because a change you make, an idea you have, you demonstrate its feasibility, the way it winds up then being realized, lots of people have contributed to what winds up being a product we use in our day-to-day. Some more than others, some more directly than others, but every little bit helps, I think, but
yeah.
I would never claim that I've done more than a little bit.
And so what have been some of those little bits of maximizing the writing?
So we got here from your question regarding what has been done more recently and what's been done there.
Yeah, let's do that.
And the reason I've taken this rather roundabout route is because some of the problems, some of the more serious problems we're facing now, I think have less to do with what we do with the ones and zeros, and perhaps as much to do with how we understand what it is we want to do.
Yeah, exactly.
So back to the car analogy.
And also looping to the anticipating future requests like we were talking about as well. Yeah.
Exactly. So anticipating whose future requests. So this is the user above, the application above, the way it's accessing the data. So the patterns of future requests you see are driven by some logic, some particular goal. Now, what if that goal or that implementation or that application isn't properly optimized for the underlying storage technology? So I'll give you a heartbreaking example, and it truly is a heartbreaking, well, it's heartbreaking for me, perhaps that's a little too geeky.
I love how geeky you are, that's great.
Well,
we are
very
geeky
kind.
too.
That is the best way to be.
Geeks for life.
Indeed. So let's take, for example, most storage devices work on a model whereby you specify the location and you store the data. Then you provide that location, you get the data back from that location.
Yes.
Right? So what if I told you that there is a magical device where you could present it with your data and it tells you where it is?
That's cool.
Or alternatively, tell it where you want to look and it tells you what data is there. Now imagine a device that could do that in a flash, literally in a flash. Now what I'm describing isn't sci-fi speculative foo. It's basically how a holographic data storage device could work.
Okay, a holographic data storage device.
Amazingly exciting technology immediately brings people to mind of thinking of, what, you mean like data crystals on Babylon 5? Yeah, exactly like that, but not exactly like that.
And so wait, this does not exist yet, a holographic data storage.
So here's the thing, the technology does. The technology's been around for actually a decade or two now, at least. And it's feasible, and it works. And it has some really fascinating properties, one of which is what I just described. You can access the data by its content and get the locations where it's stored back, or give the location and get the data stored back. If you do that with current hardware, that's an expensive thing to do. So there's circuitry in your computer that works like that, and it's expensive. And when I say expensive, I mean it's expensive in that it takes up space and thereby is expensive. So most people can't really envision that being used for a mass storage device, a device that stores a lot of data. So to clarify, the way you would store a hologram is it's an interference pattern between two beams of light. So if you make one beam of light have a certain structure to it that represents your data, and the way you do that could be as simple as running it through a broken LCD, right? Basically a grid that has pixels on, off, then you create a bitmap. Focus that at one point. Then you use a second beam, that's your reference beam. That becomes your address. Polarized, set it at a particular angle. The amazingly cool thing about that is you're storing data in a particular location in that crystal based on that angle. Adjust that angle, you're storing in a different location, different location, different location. But the word location is physically the same spot. So that's a lot of data in one place, right? So
these at different angles in the same location.
Exactly, because you would have to shine the reference beam at the same angle to get the data that you stored there.
The same angle.
Yeah.
Okay, and
so
there's like an infinite amount of angles.
Well,
a lot. There's a lot of
angles.
There's
a lot. I wouldn't say infinite because it's bounded by our ability to adjust the resolution and get
nuance and get the nuance.
Yes,
okay.
and there's also a limit on the physical property, what's actually going to wind up being recorded. So parts of it are on the nature of the crystal, parts of it are on the nature of how precisely you can control the light. There's a lot of factors that go into it. But
okay, because the crystal is what we're shooting the light through to angle it.
Exactly. Well, the crystal is what winds up storing that pattern. It would be something like a substance like lithium niobate would be what's used.
Lithium niobate?
Yeah, that's one possibility. But the point of it is, this technology has been around for a couple of decades, right?
Decades, huh?
So why don't we have it? Why don't I have a laptop with a data crystal thing? Why don't I have a reader that I plop in a little crystalline cube and draw out massive volumes of data from it?
It's still incredibly hard to read and write to it.
I wish that were it.
What's the issue?
I said this is heartbreaking.
Uh-huh.
There was a device based on this technology that you could buy. And the form it took, it was, I believe it was called the Teradisc, but I could be wrong about the name. It was from a company called InPhase. It was basically a super dense writable optical disc. Now, when you think about that for a second, you realize, hang on, you're telling me something that had these cool properties where you could look up the data just by presenting the data and get its location back. Because think about what that does for you.
It makes storage like completely agnostic. It doesn't matter where you store because you just present and you get it back.
Yes, but one of the things you do with storage is you look for things, right? You've got a database, you want to look for things in it. Usually to look for things, you would have to have some sort of a structure that you follow that's optimized for quickly searching. But how quickly? You'd still have to search. Here, you would say, here's my data. Oh, that's where it is?
Perfect, yeah.
Get me the rest of the stuff that's in that location. Super amazing, right? Sounds revolutionary. Sounds like it would change everything. Except that's part of the problem. It would have changed everything in the sense of you would have had to rewrite a lot of the software built atop of your storage system. You would have had to have people come up with applications that would exploit that particular property, and there would have to be enough of them to justify the cost of porting decades worth of legacy software that's built around this particular model of using storage and having people change the way they do things. And the cost of that wasn't justified by the coolness of the tech. It's an odd situation where your tech has to be so cool that the applications that it could enable can clearly be seen to be worth it, that people would then invest enough money to change the way they do everything.
Is a holographic storage for data the future?
I would love to say yes, but I would have to say probably not.
And so the storage is probably DNA? Is this probably the future?
So I'm very cautious about making predictions.
Yeah.
and it would depend on what you mean by the future. So what is the present? Solid state drives or magnetic drives? The answer would be
pretty solid state.
Yeah, because that's from one perspective, from the perspective of what it is you would install in your laptop, what it is you'd have on your computer.
Yeah.
But if we asked about in terms of total volume of data stored,
oh yeah,
what's the present? It's magnetic.
Yeah.
Because the bulk of our data is cat videos on YouTube and photos on videos on Facebook, right? Yeah. Or things like that.
Yeah.
And those are winding up in data centers. They're going to be on magnetic storage just for the cost per megabyte for those systems. So,
wow.
So when you ask what's the future, I'm loath to say, yeah, sure, it'll be DNA. The answer is, I honestly don't know. It depends. Sorry, I couldn't help but smile because the answer to almost any systems question is, it depends. Kind of like the economist on the one hand, but on the other.
And that's good, because then that means that you have nuance, you have multivariability to your answer rather than binary. Although it does seem as though in the very far future, it would be great to have DNA as the storage substrate. The
potential for massive capacity in a compact space is tremendous with DNA storage.
Totally. And even read-write speeds could get fast enough.
Yeah, so the reading, I get that. The writing, I don't know how fast that's going to be. But you see, all these questions, they're contingent upon how these technologies will develop. But they're not solely dependent on that. They're also dependent on us, on what we'll embrace and what applications we'll deem important, and thereby pour enough money in to make a new technology take off. So how and when a technology becomes realized is as much dependent on the human element as it is on the hardware end of it. The system software is in the middle between those two levels, and going back to the car analogy, predicting what the driver wants to do might just be as important as predicting what the engine's going to be able to do.
Yeah. Correct. So, and that's exactly what this this retrieval is kind of doing right now. A lot of that is like, what is the driver trying to do with the data? How can we optimize their quick ability to go and retrieve it?
But it's also about representation as well as retrieval, right? So,
yeah, representation.
A lot of people will take for granted, my data will be stored on this device. What form will it take? Ones and zeros. Yes, yes. How are those ones and zeros realized? Well, magnetic disks will do it one way, CDs do it another, flash drives will do it another way, but it's ones and zeros, right? Yeah, but it's ones and zeros representing what? Now, let's say your data is massive archives of video data. How you encode them is just as important as how you wind up storing them, and has an impact on how you wind up storing them. Another example could be actually the more unintended ones, like I'm going to try to restrict your ability to record certain things. And the way I'm going to do that is I'm going to say, you'd better not write any text that says something bad about me, right? Because I'm this terrifying authority, and I tell you I'm about to impose this law upon you that says you cannot write something bad about me. If I find you've written something bad about me, you're in trouble. Now the question then becomes, how have you written that something bad about me? So one of the most hilarious examples of that would be if, let's say, I decided to write a bad thing about this person, but I did it through my charitable donations. How could I do that? Mm-hmm. The answer is, I will make a sequence of charitable donations that I will document, and when you look up the sequence of my charitable donations, the amounts will correspond to different letters.
This is cryptography now.
In a sense, it's kind of like key under the doormat cryptography, not real, but it highlights that issue of it is difficult to both control and anticipate how you would represent data.
Yeah.
So when somebody tries to outlaw your ability to record certain things, there's a certain element of unenforceability about that on the technical end of it. But on the other end of it, there's also a certain difficulty in anticipating what the best way and what the possible ways are to represent data. The charitable donations example is a little silly, but it's you could imagine what's the best format for you to store your data.
And how does everyone get into a universal way of deciding to represent their data a certain way? And then that can help maximize the way that we retrieve that data.
Exactly. So one of the problems with managing storage systems is making sure people can get access to their data in the future, right? Let's make them reliable. So what do people worry about when they think about reliability? A toddler spilling a soda on your NAS box, right? That's, oh my God, something bad just happened. Or a hard drive failing, or oops, I dropped my laptop. You think about physical damage to individual devices, right? What tends to not be as well thought of, and that's where the archiving community is super underappreciated in my opinion, is looking at things like, imagine losing your data because you no longer have either the software or the physical hardware device that reads the medium that it's on. Mm-hmm. That sounds like a ridiculous situation to be in.
Yeah, because for example, Ron's got a VHS player in the back, so he's got a bunch of cassettes and he's got a bunch of older equipment back there, so he could potentially lose data because we no longer have the hardware that is needed to read.
Exactly. Yeah. Does anyone still have their zip disk readers, for example? People were using those for backup like crazy in the 90s. Or
even CDs. Nobody even has optical drives anymore.
Oh, so there was exactly, optical drives are a little rarer, but there was the funny thing about CDs when they first became used.
Especially kids today. I mean, kids today, everything's going to be in the cloud.
Oh.
I mean, what are they even going to use that's hardware except their computers and their smartphones? It's hard to even imagine them having these like thumb drives or really anything that's kind of like that.
So that's an example of why I'm really cautious about making predictions. I honestly believe CDs would last longer than they did. The way iTunes and streaming services wiped out their popularity so quickly, that I did not see coming at all.
Yeah, the streaming services, like even, it was interesting how Netflix was such a quick transition themselves from sending the CDs to the home to streaming themselves. I mean, they saved their ass. They wiped out Blockbuster and they saved their own ass.
Exactly.
Yeah, so interesting.
I mean, I'm not sure, do they even still have the DVD service? I think they still do.
That's so crazy that they still do. Some people still order them.
I have to think about it, right? And that's indicative of how quickly that transition has happened.
And so now I want to transition us to memory, because this and how this applies to humans as well, because this is another field of what you messaged me that I thought was so interesting. So dive us into this.
Okay, so again, I don't think I've ever fully answered your question about what I've been doing more recently. And the truth is, it's more focusing on the human elements of interacting with the data storage as well.
Yes.
So, and hence comes the question of memory. There's a lot of talk now about the tension between a free speech view of how we deal with data and how it's kept, and the right to be forgotten view. And some critics are kind of harsh on the right to be forgotten. They'll say, oh, well, that's a silly idea. How dare you allow somebody to tell me what I can save about them? And
this is like if you ordered a taco at 2 p.m. on Tuesday, what's the point of keeping it on the blockchain or in the data set? Like, who cares that you ordered your taco at 2? Now, is it important for your health records or your et cetera? It might be. But,
exactly.
Okay.
So the perspective of a user who's worried about how their data is going to be used, it's understandable that they'd worry and they'd want certain protections because they'd think, well, I don't want Big Brother tracking what I'm doing, right? So that sounds like part of it, but it actually comes from a slightly older place than that. It comes from a principle in French law, I believe, which, let's say you had committed a crime and you had been punished for it. Is it just for me to hold that over you for the rest of your life and punish you repeatedly? Now, how am I punishing you? By bringing it up all the time.
Yeah.
Is that cool? Is that okay? Well,
I hope that the behavior changes, and like there's a community of people around that helps the behavior change in the person, because then it's much less so that people hold it over. It's like, oh, the person has changed.
So our justice system had a certain punishment.
Good question, though,
yeah. So our justice system had a certain punishment, and you have paid it, and you have done nothing wrong since then.
Yeah.
When you have paid that price in full, is it just to punish you further? Now, if you feel things like once people have done their time, they shouldn't be denied voting rights and things like that, then you're of the mind that no, that is unjust. And if you are of that mind, then well, that's where the right to be forgotten originally comes from. This idea that you have the right, once you've paid for whatever transgression it was, to not have that held against you, the memory of it not be used against you. Right? So you look at that, and it sounds like I'm defending GDPR and the right to be forgotten at this point. But there's the dark side to it, which is this idea of how dare you tell me what I can and cannot remember.
Yeah.
And that's a very problematic tension, because this, now we're going into opinion, not fact, and in my view, the way we use data storage is effectively an augmentation of our memories. And if it is as such,
yeah,
then restricting what I can and cannot remember seems obscene. It seems a violation of the most personal kind.
Yeah.
I'm reaching into your mind and telling you, no, don't think about that. That's worse than telling me what I can and cannot say. You're policing my conscience and my private thoughts. Is that acceptable? Mm-hmm. No. But at the same time, I just made the argument that it's perfectly acceptable to not hold the memory of people's transgressions against them beyond a reasonable limit. So
it's a good contradiction there. It's
well,
good, conundrum.
Well, so here's the thing. One way to reconcile that conundrum is to distinguish between the act of remembering and the act of communicating a memory.
So you can remember, but the moment that you communicate it and hold it over someone.
Exactly, or the moment I use it in a way against someone, that becomes the objectionable thing. So trying to deal with it by simply telling people, well, you cannot remember, and I'm grossly oversimplifying the issues here. A lot of really smart people have put a lot of thought on both ends of this. So
yeah, definitely.
But my own personal view is that it is a question of memory. And it also gets to things like privacy rights with regards to your cell phones. Mm-hmm. If I tell you, look, let me take a look at your phone. Mm-hmm. And you say, no. And say, what you got to hide? Let me look at your phone. What am I doing here? Am I simply checking on your phone communications? The answer is, of course not. Your modern phone tells me where you've been, it tells me who your friends are, it tells me what you wanted to remember, it tells me what engagements you've got coming up. Mm-hmm. It is a supersized version of the private papers of John Wilkes, right? Yeah. Which was the whole reason we have a Fourth Amendment in the first place, was a lawsuit before we were a republic, where a leaflet was written insulting the king, right? And so a general warrant was used to find out who had written it. And so people's homes were searched, their papers rifled by agents of the crown. And this guy, John Wilkes, was found to have written it. And so he sued the crown. for violating, basically violating his conscience was what that wound up being, and he won. So this was before the United States was a republic. This was the time when we were still colonies, and
now we face the same thing with.
And now we face the same question, but when we're talking about something that is even more personal than your private papers, because your private papers are what you consciously write down. Your phone includes things that you don't consciously include in there, but are of growing necessity to your daily life. So as an invasion, it's even worse. It's not a Fourth Amendment violation in search when you do that. It gets to the point of being a compelled testimony. In fact, that court case that was the Wilkes case, I may be quoting the wrong one there. I do apologize. I am not a lawyer, so forgive me if my knowledge of the particular case law is a little off. But one of the comments that was made in defense of the ruling was, either in that case or a later one, was that to hold a person's private writings against them was as obscene as holding their thoughts against them.
Yeah.
And to take them without permission like that, or without cause, without a specific warrant for it, was equivalent to forcing a person's conscience to testify against them.
Yeah, yeah.
Now, that was way before we had cell phones that knew so much about us. So when we look at a cell phone today, the way we treat the data on it honestly needs to be more respectful of it, as if you're peering into someone's mind, not as if you're searching somebody's private papers. And so issues surrounding what we can technically do to make questions like that more forefronted. So there's,
I like how you called it the augmentation, right, of humanity. It's our augmentation. It's making us better. We're storing all this useful data on it. But then it's also kind of as an augmentation of our mind, then when people are aiming to observe that data, they are then peering into our mind.
Yes.
And so then when you ask me the question, like, can I look at your phone, right? So then the question is, you have nothing to hide, right? And it's like, okay, yeah, I have nothing to hide, look at my phone. The idea is that you can then see all of the data, but then the moment that you choose to use that data against me, or even beneficially, you can use that data for me by saying, Alan, I've seen that you've been going to this destination every day the last couple of days. Would you like me to call you an Uber to this destination? Or would you like the certain order of this service because you've been doing it over and over again? So if they're using the data to benefit me, then it's...
Is that a bad thing?
Is that a bad thing?
Well, you skipped over a point there, which was the peering into your mind part.
Yeah, that's a big one.
So yes, so I'll peer into your mind in order to offer you helpful suggestions.
And then is it okay?
Which of those acts is the problem? Now, the offering the helpful suggestions is not a problem on its face, but the peering into your mind without telling you, that's a problem, and that's an act.
But we just click on the accept terms and conditions button, which is saying, okay, you can peer into my mind.
And in that case, whose fault is that? Now, the answer is partially all of us.
Yeah,
not just the provider.
We haven't quite created the ideal collaboration between the technology engineers, designers, and business, as well as the consumer of that, as well as how the data works with that, as well as how they get money from that, and we get money from that data, who owns that. So that whole ecosystem is going to take an interesting next couple of years, a decade or so. Let's see what happens.
And let's not forget information, education and communication. So when you read the terms and conditions and accept them, how many people honestly understand them all? how many people actually read them
Probably
all? For the
one
first?
out of every couple thousand, 10,000 probably actually
Who knows?
read it. Yeah.
But it's way less than we expect.
15-minute timer.
Oh dear.
Thank you, Ron. Flip that over.
So yes, so the peering into the mind part is the act without permission.
Let's make sure we get to the most important things that you've been learning. So you said peering into the mind is this most important problem without permission, but we give the permission.
We give the permission, but do we give knowing consent or not? So the way some terms and conditions work, the answer is maybe not entirely. Now, is that the fault of the provider of the service? Or is that the fault of the consumer of the service not being better educated? Do both of them have to meet each other halfway perhaps, or some way? Definitely.
Do we have to write that in big, bold, capital letters, like as the only sentence at the very top is you give us permission to peer into your mind to make your life easier?
No mind melds without permission, right?
Yeah, that's interesting.
Well, that's part of it, right? The part of it is the peering in. And the remembering is a separate thing, right? Because it's related, but it's not the same. So I look into your mind, I can look at what you've remembered. Now, what about what you consciously remember? Am I allowed to regulate that? Now, that's a huge problem. Because attempts to do that are a form of censorship that is unbelievably invasive and potentially very creepy. But it's also possibly unenforceable, right? I'm not going to let you remember this one detail. It brings to mind those arguments about when the fans of digital rights management were attempted to copyright a number at one point. It was like ridiculous, right? But at the same time, what it demonstrated was how many ways you could get around sharing that number. It's like, you know what, okay, I'm not allowed to share that number. Okay, how about that number minus 1 plus 1? I haven't shared that number, have I? Or have I? So there's the enforceability aspect of it, but the question is, there's also the obscenity of attempting to enforce something like that. It is not good.
So you say that if we start treating data as memories and making it more clear that this isn't augmentation, it's an appendage, it's an addition to humanity, our devices and our data, then if we treat that data as memory and we make this general data and privacy rights more about piercing our memory, then I think the whole conversation will be shifted towards a more like let's take this a little bit more seriously because this is their memory. This isn't just data, it's in memory.
Exactly. I would say it's not that we should treat it as such, it's that more people should understand it as such.
Understand it as such, yeah.
Because lots of very smart people are grappling with the ethical questions around how we manage data and how we deal with data.
I mean, just the way that you're describing this right now, I'm starting to think of everything differently. So my phone call log, my texting, my calendar, my email, my everything on my phone is memory. As in, it's the memory trail of what I've done. So I can look back and see who I've texted, when I texted them, at what time. I'm not viewing that as data anymore. Or at the same time, I am viewing it as data, but I am viewing it more so as memory. And therefore, it's like somebody going into who is Alan? How many times did they message this person? At what time? Where were they at these times? And so that becomes a serious thing.
Because what is data if not recalled, right? And what are memories if also not recalled?
Yeah, because that's like the fallen tree in the forest. If the data is not recalled at any time, then does the data even exist if it's never recalled?
Yes. If it's never touched, if it's never ever read again, ever.
Yeah. Yeah.
Then what difference would it make if it was or was not there?
Yeah. So then where does I guess a quick question before we ask you some of the questions that we typically ask on the show, and I'll segue into the questions we ask on the show by asking you a question that we have asked people on the show of a similar field as you, which is that what's kind of like gonna happen is in your best approximation as we kind of transition to a world of more globalization and more open source, hopefully, less nationalism, more globalism, less individual privacy and more openness, more open source, maybe through technologies like blockchain. Maybe we can get there now, and very strong cryptography in the case of malevolent players. Where do you kind of see that whole mix of data and where we're going with accessibility to that data as needed, accessibility to the memory as needed?
Oh boy. So that is an amazing question. If I may rephrase it slightly.
Yes, please.
What's going to happen as we grow more connected?
Yeah.
Right. Well, because being able to peer into someone's mind, also almost literally in some cases, is ever growing, right? Our ability to share our ideas and thoughts across distances and across time is increasing. That makes us more connected, both over space and time.
Yes.
So the inevitability of being good neighbors, the inevitability of the importance of being good neighbors to each other on the individual level and on a more global level, that's never going to go away. Mm-hmm. It's just going to become more important the more able we are to reach more people and the more able we are to form more distributed yet more insular tribes. That's a problem. And the way to deal with it, in a way, whether technologies that help with that or whether it's through our own understanding of how we interact with technology, has to take that into account. What it ultimately boils down to is, what kind of a neighbor are you? What kind of do you feel a part of a society or not? Mm-hmm. And how much a lot of our problems go into this application of labels. So as an example, forgive me for this rather random story. British comedic writer and performer John Finnemore wrote a comedy sketch once where a man sits down and starts declaring his intent to eat a delicious banana. The woman next to him then responds, "That's disgusting. Surely you'd rather eat olives because they're delicious, but bananas are ick." And he then goes on to defend the banana, and then she argues back with him, and after a back and forth, he proceeds to eat the banana, at which point she says, "What are you doing? I thought you were going to eat a banana. Why are you eating an olive?" So at the end of that sketch, it was a radio comedy sketch. You're left not knowing whether the man was eating a banana or an olive, mm-hmm. but you're left with a very clear impression that they both had applied different labels to the exact same thing. Right? So when you talk about data storage, one layer of the software that goes over there is all the data that represents the data that you're holding. So the most common example of that is your file system, which gives names to individual data objects. And some file systems are better than others at giving multiple names to the same thing, but if we're not careful about the language and what we mean by what we say, we can easily wind up miscommunicating what it is we mean. So when you see tribalism against and nationalism fighting against globalism, very often you'll see somebody saying, well, that person's bad because they're a member of Team X, but I'm a member of Team Y. Team Y is the good team. when what they really mean is, I think label Y applies to goodness, and the other person thinks label X applies to goodness,
Yes.
and they don't really disagree on what they think they disagree. So where do I think all that's heading? The better communication, the better education means we should be embracing technology in a more effective and ethical and efficient way.
Mm-hmm.
And on a more global scale, that's like what you do on a micro scale when you're talking about system software or storage system software, managing things more effectively. But
yeah,
sorry, I
that's
had to put that
was
pitch
good.
in there for.
And in our path to get there, there's going to be a lot of chaos, and there's going to be a lot of these mishaps that occur, and hopefully they don't inflict a lot of suffering onto us along the way. Hopefully
not too much.
Hopefully not too much.
I have faith in people being ultimately awesome in the end.
I really enjoy how my mind's been expanded to understanding data as memory and like peering into the mind of someone. That's kind of now what it feels like. It's now I really appreciate the way that my mind's shifted in that sense, and I hope that same things apply to a lot of the people that have been viewing. Okay, a couple questions on our way out that are related to what we ask our guests on our show. The first question is, what is the most beautiful thing in the world?
Everything you see and that lasts in your mind.
Everything you see in the glass in your mind?
No, and that lasts in your mind.
Oh, everything that you see and lasts in your mind.
Every experience and pretty much every breath and every moment.
So from the moment you're born to the moment you die, everything you experience.
Yeah, I mean, the fact that you get to do that.
The fact that you get to do that, yes.
I mean,
that you were
how
given
lucky are we?
This consciousness, yeah.
Exactly.
Yeah.
I mean, there's the problem of evil, right? And that's not a beautiful thing, right? Ugliness and pain and suffering are things we must all try to ensure that there's less of in the world.
Yes.
But the fact that overall, I think people tend to be on the side of minimizing that, regardless of how they might express that desire and how they might misunderstand that desire in others. That is a beautiful thing. So the fact that we get to be a part of that.
So that's, of course, birth to death, all the experiences in between, most beautiful thing. How about, do you think we're alone in the cosmos?
Oh dear, that is a tough one. I think we worry too much about seeking an other that meets our definition of what an other is, when there are so many others that we do well to better communicate with right now, or better understand right now, whether it's others in terms of other people or other perspectives, or whether it's others in terms of getting a better understanding of our world around us. So the short answer is, I don't know. I'm comfortable not knowing and being amazed one way or the other, should we be able to figure it out.
Mm-hmm.
But in the meanwhile, I'd say, rather than bemoaning the lack of encountering something wondrous out there, it's a good idea to not overlook the number of wondrous things we encounter out here too.
That's good, yeah.
Sorry if that sounds a little trite, but I'm
No,
not saying let's not
that.
explore. I'm saying let's do it. But let's keep our eyes open to all the wonder and beauty around us right now too.
Right now, that's good. Yeah, it's a good memory to bring back our attention to the beauty of the body and the environment, the community, everything we have here as well. All right, how about, do you think we're in a computer simulation?
Ah,
Ahmed, look at this.
oh dear. Are we in a computer simulation
The
or
delay. Look, there's you. And there's you. And there's
There's me a moment ago, and a moment ago, and a
And a
moment
moment
ago.
ago.
We're looking into the past. So that's another one of those questions where I do not know. I would rather have a better understanding of what we mean by being in a computer simulation before ever answering a question like that.
Maybe we just give a quick, just being able to compute
Well, one of my
your
favorite
life and all life.
Well, one of my favorite authors, Douglas Adams, right? Remember the plot of The Hitchhiker's Guide to the Galaxy wound up in, I believe, the third volume, revealing that the Earth was a computer meant to calculate something. So are we part of a simulation? Oh no, we might actually be the electrons in the chip, right?
Hell yeah. Just seeing how the human experiment unfolds.
Exactly. So are we in a part of a computer simulation? For some definition of a computer simulation, probably yes. Sorry. I can always get out of it by redefining the terms.
Yeah, yeah.
Labels matter.
They do. They do. I feel so like the way that I was understanding things before is now changed because of our conversation, and it feels really good. Like I feel very empowered because of that.
It's wonderful.
Yeah.
So glad I wasn't a corrupting or disheartening influence.
Not at all. Not at all. Quite the contrary. It was I think that the way to understand data as memory, it changes the way we perceive the way we engage with our devices. And then it changes the way that we think about data privacy, memory privacy, as well as memory accessibility, how quickly we can access these memories, as well as the architecture of the hardware, the architecture of the software, how to access them quickly, how quickly we can pull them up, but also with the memory, when can we give that memory to other corporations or businesses or entities that they can then make our lives better by having access to that. So it's this whole big mix. We're going to be using digital data in DNA, hopefully, in the future for storage substrate, rather than these massive, like you were saying, these hopefully yottabytes of
$100 trillion worth of magnetic disk spinning, right? That's an insane number.
Nonsense. It's nonsense. So it's a huge field that is, data, memory, systems, storage, all of this. And thank you so much for coming on the show and teaching us about this.
Thank you for having me, and I hope I haven't been too meandering.
Not at all. Not at all. This has been such a pleasure. Thank you.
Likewise, Alan. Thank you.
Thank you. And thanks everyone for tuning in. If you guys had a good time, make sure to give us a subscribe, join the family, give us a comment below with your thoughts. Make sure to take some of the content that you've learned from here and share it with other people. As in, go ahead and make a blog post about it, go make a video about it, go write something about it, teach it to other people. We'd love to maybe start a company about it. There's so many cool things to do. Go create. Don't just consume, go create with it. Join us on Patreon, help us sustain the studio, help us sustain the project, keep growing it. We'd love to have you join us. Thanks for joining us, Ahmed. Thank you.
Thank you, Alan.
Greatly appreciate it. Ron Vargas, our producing director, thank you very much. And we'll see you guys soon. Peace.